All right, here we are. Welcome back. So we are sort of wondering when to use what. There's still a little bit of confusion, which is totally fine because there are so many tests that we've done so far, and there's a lot of overlap between a lot of them, right? But let me just lay it out, flat out for you, and if there's still confusion, let me know, and we can do some more clarification. Okay, so we're just talking about t-tests and ANOVA because they're all testing the same thing, right? They're testing differences in means, okay? Now we have our z-test, and we've only used z-tests for proportions. There's a few other instances where you can use z-tests to test means, differences in means. I didn't go over it in this class only because t-tests are a little bit more kind of robust. I think, at least between the two. So we only use z-tests when we're talking about proportions, or testing proportions, okay? So that's that with proportions. And z-tests is the only situation for this class that we use z-tests in, but we've got effectively 4 different tests that we can do for 4 different situations, okay? So I've got this nice table here. At least I hope it's nice. But I've got this kind of laid out, and I've got some other examples too. But let's just take it one sort of row at a time. So we've got what we're testing against, right? Kind of the nature of the data, the number of groups therein, and then the test that you'll use, okay? So with proportions, we already said we just sort of ignore the fact that it's only one group, which we've got here. So it's not necessarily independent or dependent. It's just one thing, right? So we've got one group here. We're going to be doing a z-test, right? So effectively one column of data, okay? And then if we're just testing against a known value mu, okay, a known value mu, and we also only have one group, then it's a one sample t-test, okay? One column of data, right? Testing against something that we already know. Okay, so we don't have to go out and calculate this. We only calculate things that are oriented around the one group that we have. Okay, and then when we're testing against the difference in 2 means, right? The difference in 2 means. Well, we've got 2 groups. If we have 2 groups that are totally independent, right? 2 groups that are independent. So they're 2 groups of different people, males and females. Income bracket, 2 different income brackets, that type of thing, undergrads, graduate students, that sort of thing, right? Then we would do a 2 sample t-test to test the differences between those 2 totally unrelated groups, right? Or at least hopefully unrelated, okay? But if we have a situation where we are testing the difference between group 1 and then that same group after a period of time, or some sort of intervention, then it's the same people, pre and post, then you can only do a paired t-test, right? And that's like the strongest type of test as far as t-tests go, because your research design is incorporating the fact that person A is going to probably vary the same after a period of time. Same thing with person 2. And person 2 after some period of time, right? So that is when you have, again, the same people in both groups, right? There's just a period of time in between when you're measuring something, whatever it may be. And then if we have a bunch of different means, right? So we've got mu1, mu2, mu3, mu4, up to mu, however, right? They're all independent. We're going to be doing an ANOVA. So this sort of situation here is you have to do an ANOVA first, right? First, just to see if there is any differences between the groups that you're testing. And it's always going to be more than 2, right? So 3 or more, okay? But everything here is always 2 groups, 2 columns of data. And then it's just the nature of them, right, that you look at. If there are 2 different groups of people, right, males, females, for instance, then you're looking at 2 independent groups. But if you have the same people pre and post some intervention, or pre and post some period of time, or have the same plot of land after some period of time, right, then you want to do a paired t-test. That's the only kind of test you can do, right? You cannot do a paired t-test in this situation. You cannot do a two-sample t-test in this situation. It's against the rules, right? Okay, so this is the table form. Let's look at it from some clip art form. There's a fruit flying here. Dang. Okay, sorry. All right, so a one-sample t-test. What we're doing here visually, we've got these four people. This dude, okay, so whatever, these are all clip art people. This dude looks like the president of Brazil. Jair Bolsonaro is his name. Anyway, I think it's him. He must have been looking for extra money or something. Anyway, so we've got this group of people, and we're going to summarize them with X bar, right? So we might be measuring heights, right? So if we were to take all of these heights, add them up, divide it by 4, we'd get some X bar, right? And then the question is, do we have enough evidence to say, based on, the nature of these data here, these people, do we have enough evidence to say that they are statistically significantly different than this one thing that we know, right? So this could be like some kind of population average. This could be, the average height in the U.S., average height in some country, Brazil, average height of the world, right? This whole thing, right? We're just comparing these people to some already known value. We can kind of look at it as just like some structure, right? We've got this thing that we calculated based on these 4 people, and we're just seeing whether or not we have enough evidence to say that they are different from the population value, right? So is there a difference between this group and a previously known mean, or some known mean? Yeah, very cool. Okay, so we've got that. It's the one sample t-test because we only have one sample. All right. A two sample t-test or an independent t-test looks like this, where we have 2 different groups containing different people, right? So we see that there, I think, let me make sure. Yeah. So there's no duplicates here, right? Everybody is totally independent from the other, right? So then we just summarize, if we're looking at heights, for instance, right? We would take all these heights, this little kid's height, it's really screwing the average. But we would find that this is going to be some X bar 1 and some X bar 2, and then we just use an independent t-test to figure out whether or not they are statistically significantly different, right? Is there a difference between these 2 independent/unrelated groups, right? Okay, so that's that situation, and this is when you would use an independent t-test, and only an independent t-test, okay? In this situation, you would only ever use a one-sample t-test. You can only use an independent t-test or a two-sample t-test in this situation. And then in the situation where you've got the same people just after some period of time, well, then that's a paired t-test, right? So we've got some persons, I don't know, maybe instead of heights, because that's probably not going to change, we could say that we're looking at, I don't know, maximum heart rate, okay? Oops. And we want to see if some exercise program changes the max heart rate, right? So all we would do is look at the difference between this person before the exercise program and them right afterwards. And then that's going to be some difference, right? Okay. We look at this little kid and measure their maximum heart rate before the exercise program, give them the exercise program, find that difference, right? Same thing with this old guy over here, find some difference. And then what we do is, based on all these differences, we take the mean of those differences, and that's D bar, right? So we've got the same person each time, right? We've got no different person, right? We're looking at the same group of people, right? Just at 2 different periods of time, essentially. And then that's that, right? So then we find our D bar, or it's given to you, and then you do a paired t-test, and only a paired t-test, right? Now, I remember I taught y'all how you can kind of cheese a one-sample t-test out of this, but it's doing the same thing, effectively. But in this situation, right, we're doing a paired t-test, and then that's that, right? Okay, so hopefully that sort of clears things up. Oh, no, we still have one, and then ANOVA, right? Where we've got all these different clip art people found in 2020 PowerPoint. Thanks, Bill Gates. But now we're just seeing whether or not this group is different than this one, and this one, and this one. And then whether this group is different than this one, and this one, and this one. This group is different than this one, this one, this one, right? And we can kind of see where that's going, right? So we're just saying, based on all these things, right? We could be looking at heights or looking at income or something like that, right? Then, right, we would need to do an ANOVA to then see which one of these groups are different, right? That's essentially what we're doing. Okay, hopefully that clears things up. Hopefully the pictures kind of make sense. And if they don't, let me know, and then we can review it just a little bit more. Easy peas, right? Easy peas. Okay, so we're going to move on to the next loose end, and then, well, I guess I'll see you there if you want. And then that'll be that. All right, see ya.